In the previous lecture, we have learned about ASCII codes. Now let us talk about Unicodes. ASCII codes are only for English language. Now when computers started supporting various other natural languages, they have to define the codes for each and every language. So just like English, for every language codes are available. For every language codes are available, separate codes. Like for German separate codes are there, for French separate codes are there, Siberian separate codes are there, Hindi separate codes are there. For every language separate set of codes are there, and those group of codes combined together are called as Unicode. Here uni can be termed as unique code or unified codes. Unified code means codes of all the languages are combined together are called as Unicode. Or universal code, because these are common universally, everybody follows these codes. So what about English? English is also included in this Unicodes. English is also included. So Unicodes are the group of codes or the set of codes for all the natural languages. Now English language is having just 26 alphabets, lowercase, uppercase together makes 52. Apart from that, special characters and all. Now when the codes are given for various natural languages means, then its scopes or range becomes very lengthy. Yes, so English language codes or ASCII codes, they used to take 1 byte only. But Unicode takes 2 bytes. But English is also included in Unicode. So if you are using English alphabets in Unicodes, then it may be 1 byte. If you are using other languages, then it may be 2 byte, or it may be 4 bytes also. It may be 4 byte also when it is supporting some languages whose codes are much larger. So Unicodes can be of 8-bit. Unicode can be of 8-bit, or so that is 1 byte, or 16-bit, that is 2 byte, or 32-bit. So for representing Unicode, there are some formats followed, that is UTF format, Unicode transformation format, that is called as UTF-8 or UTF-16 and UTF-32. These type of formats are followed. UTF-8 means it may take either 1 byte. This 8 means it allows 1 byte, 2 bytes also, 4 byte also. 16 allows 2 bytes or 4 bytes. 32 is constant, always allows 4 bytes only. 8 doesn't mean 8 only, but minimum 8, maximum it can take up to 32. When you say 32, it doesn't take minimum, it always takes 32 only. So these are the formats followed are supported by Unicode. Now let us look at some codes for various languages. How I want to know, if I want to know the codes for some language, then how I can do that. So let me show you where to find out the Unicodes and how to use them. Okay, in browser, you can type the URL unicode.org. Then this is a website where you will find all the Unicode. This is the home page for the website. And if you scroll down, at the bottom you can find code chart. Now it is showing various languages. Various languages are there. Now in this you can see they are grouped also. This is European script. Here you can see European script and African script or South Asian script. The various scripts are there. I'll select Greek. Now these are the codes for Greek language. Pi. What is the code? 03A0. 03A0, that is pi. A, that is 0391. Phi, 03D5. So if you know Greek letters, you can read them. And there is a symbol. Theta is 0398. Yeah. So these are all Greek symbols or script symbols, and their codes are given. So you can find more details given below. So if you are familiar with Greek language and you want to use Greek language in your Python programs, then you can use the Unicodes for this one. Now how to form a letter for this one? Suppose I want to find out, I want to write a letter, I want to write a word that is alpha 03B1, beta that is 03B2, gamma 03B3. I want to use these three. How to represent this in our Python program? Now watch this, how to use this Unicodes. I'll open IDLE. I'll form a string /u is for Unicode 03B1. I will close this, that's all. I will print S. Now you can see alpha is printed. I will again form a new string /u 03B1. Next is one more letter /u 03B2. I can use capital letters also. Then one more alphabet 0/u, that is 03B3. Quotes close. Oh, I missed something here. Yeah. Okay. See, I have given O here instead of 0. O here. So you can say that it is giving me the error position, that is from 6, 7. There's an error. So I have mistyped, so I got the error. Let us try it once again. /u 03B1 /u 03B2 /u 03B3. Quotes close. Print S. Alpha, beta, gamma. I got the Greek letters. Alpha, beta, gamma. So this how you can make use of Unicodes. Now what about English alphabets? If I use English alphabets, can I use /u 0041? This is the hexadecimal code, you know. All these are hexadecimal codes. These are hexadecimal code. So we already have seen in the previous lecture that 41 was the hexadecimal code for capital A. Let us check. Yes. So you can use /u as a Unicode for English language also, because English language is also part of Unicodes. Next. Every code is called as code point. Every code given for every alphabet, all these are unique. Every code represents a unique alphabet and all these are in hexadecimal. So each of this is called as code point. Each of this is called as code point. If you want to check any other language, you can go back. I will just close this chart. Let us look at other language. I will say code chart, and in this I will use an Indian language, that is Devangiri. Devangiri means, oh, it's Hindi. Yes, Hindi Lipi or Hindi script is called as Devangiri. So you can see that all the hexadecimal codes are starting from 9, 09, 09, 00, 09, 01. So if I take the alphabets from here, ka, kha, ga, gha, that is 0915, 0916, 0917. Now I can choose the alphabets here and make a word like Python, or I can make any Hindi word. I will just try this. You can try the other words. I will take ka, kha, ga, gha, 0915 and 1617. Let us go to IDLE. I'll form a string S assign /u 0915 is for ka, /u 0916 is for kha, then u 0917 is for ga. S, if I print, I got the letter ka, kha, ga. So that's it. So you can use the Unicodes like this. For any language you want, you can go to the charts on that website and you can find out the letters. And if you are working in a particular language, then you should remember the codes so that you can smoothly use them. That's it. Now the next point. I have letter A. So if I print, this is A only, right? Now I can use this one /u 0041. So I get, 41. So I get alphabet A again. This is in 4 digits of hexa. So this will form total 16 bits. Because one hexadecimal digit takes 4 bits. 4, 4, 4, 4, total 16 bits. So we are mentioning this in 16 bit. Now can I mention this in 8 bit? I will just try this. I will mention A only. /u just 41. No, it's an error. Then I can mention in just 8 bit like this. I can take x/x/x41 just to see the bottom of the screen. So if I print S, it is A. So you can mention the Unicode by using just 2 hexadecimal digits also, but you have to use X. If you are using 4 hexadecimal digits, then you have to use /U. So we have seen Unicodes for 1 or 2 languages, and also it includes English language, and they can be represented in 8 bits or 16-bit or 32-bit depending on the range or the value. So we learn about Unicode. For every character, codes are there that are called as code points. Now, planes. What is this? What is this? Let us see, talk about this one and also about digraph. I'll explain about this one. See, I'll go to browser and explain. Here I will search for Unicode planes. I'll click on one of the link here. Now let us understand what does it mean by plane. See, the Unicodes starts from 0000 and lastly it is 10FFFFFF. So how much this is? This is around 11,14,000 something. 11,14,000 something. So 14,112 I think. So if you convert this into decimal, so ASCII code can range from here to here. So this is divided into planes. This is divided into planes. So there are total 17 planes. So you can count them. These are all 17, and some of the planes are not in use, and some of the planes are used for assigning the codes for different languages. I'm just giving the rough idea here. See, when the codes are smaller in size, they may take just 1 byte. So UTF-8. If the codes are bigger, they may require 2 bytes. And if they are more bigger, they may require 4 bytes. Depending on the size of the memory required, that is size of the code, the memory required may change from 1 byte, 2 byte or 4 byte. That's what the point I have to explain. So the Unicodes are divided into planes, and those planes require different size memory. So that is the reason different formats are followed. UTF-8 and 16 and 32. You will find a lot of files in the form of 8 and 16 and 32 in internet. So that means like this. So if you're using English language, then UTF-8 is sufficient. This will take less memory. If you're using UTF-32, then it will take more memory. And in that, if you are using English language, then you are wasting the memory. So you should use UTF-32 only if the language is falling in the larger size planes. If it is following in smaller size plane, then use 8 or 16. So that's how this is useful. Now lastly, digraph. See, some languages will have letters or characters which combines 2 symbols together. Like in Siberian language, these 2 letters are combined together, and this is read as Z. This is read as Z. Like if you know Hindi, then like M, this is included together. This is I and this is M. So 2 are combined together. Actually it is forming a single character, but this is including 2 symbols. Like if you use Arabic, this is Ka and this is Ha. So these are combined together. So this is forming Ka, but actually these are 2 different letters, 2 different symbols, Ka, K and H. So these are combined together. I am calling them in English. So K and H combined together is forming Ka, but together is a single character. So such characters which are formed by taking 2 symbols together are called as digraphs. Digraphs. These are special type characters. So I have just highlighted them, explained them here. You may come across them later in the course. So that's all in this lecture. So what all we have learned about Unicode. Unicodes are given for all the languages, and for every language, for every alphabet, there is a unique code. And the languages which are using smaller codes, that are smaller values, are required just 8 bits and then 16, then 32 bits. So they are divided in the form of planes, 17 planes. So depending on the plane, the size of memory is required, size of memory is used. And then we have seen digraphs. So that's all. This was just the sharing of concept about Unicode, and the previous lecture I have discussed about unique ASCII codes. So you should know these basic things. These are the simple and the basic things. And if you want to explore more about them, then you can search in Google or you can visit Unicode.org website. So that's all in this lecture. We will be using these things in coming lectures.